Welcome back to another installment on linear inequalities and graphs. The problems that you will see in this particular videos make up for a unique class of problems because they present unique set of challenges, and every problem is unique in its own perspective. And that's why I handpicked these problems to be part of this series of videos. So without further delay, let's get started. So far we have not graphed an inequality at all. Not only in these series of videos, but even in my inequality videos that I have presented before, we have not graphed an inequality as it is using the 4 quadrants, okay? So in these videos, we would either construct a graph or interpret a graph to determine the inequality, okay? It'll be one of these two kinds. So without further delay, let's get started. So in the first problem, you have 2y plus x less than or equal to 4. First, write it as if the expression are equal to each other, okay? In other words, 2y plus x equals 4. Why are we doing this? That's the question. Why are we doing this? You have to ask the question, because if you're going to draw a graph, okay, whether it's linear or not, you need to know slope, especially for a linear inequality. You need to know the slope. Do we know the slope? We don't at this moment, but we can determine it. What we could do is we can add negative x on both sides, which would make it 4 minus x, and then we can divide by 2 on both sides, which would make it y equals 4 over 2 minus x over 2. This can simply be written as y equals negative x over 2 plus 2, right? In other words, y equals negative 1/2 x plus 2. Therefore, slope is negative 1/2, right? So to determine the y-intercept, you can substitute x equals 0 implies y-intercept equals 2, right? Now let's go ahead and construct a graph. These are basic items that you would need before you can do it. So this is your first quadrant, this is your second, this is your third, and this is your fourth quadrant, right? We know our slope is negative, so our line is going to be slanting down, right? But before we construct the graph, we have to know where it is, which axis it's touching, right? So this is your x, sorry, this is your x, and this is your y, right? So we know when x equals 0, which is 0, 0 right here at the origin, y-intercept is 2. So if you say this is 1 and this is 2 and this is 3, this is negative 1, just for time being, negative 2, negative 3. So the line is cutting through right here. Of course, I don't have a ruler, so I can't draw my line perfectly straight. So it is cutting through this. This is the key, because we know when x equals 0, y equals 2. And this is a negative slope of negative 1/2. So we have constructed a line now, right? So what are we going to do next? We have to figure out under what circumstances is this, or in other words, which area are we shading, right? In other words, because this line is not passing through the origin, we can substitute y equals 0, x equals 0, okay? That means 2y plus x is less than or equal to 4. So that means 2, okay, times 0 plus 0 is at less than 4. Yes, 0 is less than, it's not equal to 4, but it's definitely less than 4. So this statement is true. That means we shade, right, all the areas containing the origin, right? Because we substituted, keep in mind, we have the liberty to substitute x equals 0 and y equals 0 when this line is not passing through the origin. If it's not passing through the origin under any circumstances, we have the freedom to substitute x equals 0 and y equals 0. That means Because, and it's also a true statement, right? When we substitute in, we see that 0 is less than 4. So it's a true statement. That means we can, and then that means we can shade all areas, right? All areas below this line, because the origin is below this line, right? I just put some lines so that this area under this line, what corresponds to this inequality. Does that make sense? Why we shaded this side and not above? Because if I shade above, that does not capture the origin, because we use the origin to determine whether the inequality is true or false, right? So it has to capture the 0. So if I have to shade the above, then 0 is below the line, then that's not going to work. It's like a barrier. It has to include the 0. So that means that's why we shaded this areas. That means if the question does ask you which quadrant is not captured by the inequality, well, the inequality captures all quadrants, right? The shaded line, the shaded line is in almost every quadrant, so it captures all quadrants, even though that's not part of the question. I want you to know, because there are questions related to this concept as we move further into the video, right? So that's how you graph this inequality. I know it's a lengthy problem, but there is no getting around it. This is how you do it, right? So let's do the second problem. So we have 3x minus 2y greater than 2, right? So again, just like we did previously, we have negative 3x minus 2y equals 2. So negative 2y equals 2 minus 3x. So we can divide by 2 throughout. So negative y equals 2 over 2 minus 3 over 2x. We can divide by negative throughout. So y equals negative 1 plus 3 over 2x, right? In other words, y equals 3 over 2x minus 1. So that's your slope, and that's your intercept. So x equals 0 implies y equals negative 1, right? So let's go ahead and draw the graph. So we know x equals 0, y is negative 1. So negative 1, negative 2, negative 3, so on. And it's a positive slope, right? So it has to cut straight through this 1 into this, right? So this is your slope of plus 3/2, right? Now let's go, because again, this does not pass through the origin. You're welcome to substitute x equals 0 and y equals 0, right? Right? So that means so how do we do this? So we can do 3 over 0 minus 2 times 0. Is it greater than 2? 0 greater than 2 is false, right? Right? I just substituted 0 for x and y, right? Is 0 greater than 2? It's a false statement. Because it's a false statement, we cannot capture the origin. Previously, if you see here, the statement is true when we substituted x equals 0, y equals 0. So we captured the origin. Here, when we substitute x equals 0 and y equals 0, 0 is not greater than 2. It's a false statement. So we can capture this area above the line. It has to be below the line. So all of this area below the line is what is captured by this inequality. Now, which quadrant does this graph not represent? This second quadrant, right? There's not a single area shaded in the second quadrant, whereas the first is shaded, fourth is shaded, and third is shaded. So all areas of these three quadrants are captured, whereas the second quadrant is not captured. Why? Because the 0, 0 we substituted results in a false statement, so the origin cannot be captured. Hence, the area below the line is captured, just like here, but they have different reasons on why we shaded each areas. Does that make sense? I know these problems are rather complex and sometimes can be lengthy, but I don't think there's any way to get around it. All right. Which of the following inequalities represents the graph above? Something I forgot to mention is if you have a solid line, that means it represents either greater than equal or less than equal, okay? I'm not talking about the XY lines. It's the line other than the XY axis lines. If it's a solid line, it's greater than or equal. If it's a dotted line, it can be greater or less than. Just it's similar to how when we said a solid line corresponds to greater or less than equal to, an open dot corresponds to a greater or less than, just like that, right? So there's a dotted line running straight through the x-axis, right? That means y-intercept is 0, right? When y equals 0, x carries some value, right? So this is 1, this is 1, 2, so this is -1 and -2. So x equals, sorry, I meant to say x equals 0, y equals -2, right? I meant to say x equals 0, y equals -2. Apologize, right? Because this is where the axis is, right? It's infinitely -2 on both sides, right? In the whether in the third quadrant or fourth quadrant, it's running straight through it, right? And if you notice, the origin is captured, right? That means it's all above the axis that's y equals -2, right? So that means if it's greater, that means we don't say y is less than -2, we say y is greater than -2. So that means y is greater than -2. Okay. Let's look at this case here. Here, we have to first figure out what the slope intercept form is before we can proceed further with the problem. We are given two values of ordered pairs. We have -3, 0, we have 0 and 2, right? So let's call this x1, y1, x2, y2. So slope equals y2 minus y1 over x2 minus x1. So that is 2 minus 0 over 0 minus of -3, which is 2 over 3, right? So slope is equal to 2 over 3, right? In other words, y over x equals 2 over 3, right? That's what it literally means, right? So 3y equals 2x, right? Does that make sense? Because slope is y over x, right? So y over x equals 2 over third. So if you cross multiply, that means 3y equals 2x. So in other words, let's actually even show you differently. Y equals mx plus c, right? So we know slope is y equals 2 over 3 plus x, right? So if you multiply by 3 on both sides, we get 3y equals, that's how I got this one. But if you may wonder, how do I solve for the intercept? Which is why I'm showing it to you this way. So 3y equals 2x plus 3c, right? If I multiply 3c, right? Now substitute x equals 0 to get the y-intercept, right? Right? Or you can substitute x equals 0 and 2. So x equals 0 and y equals 2. That means y equals, we don't need to do this extra step here. We can save this. So y equals, so that's 2 equals 2 over 3 times 0 plus c, right? So That means c equals 2, right? So y equals 2 over 3x plus 2. Now we have our slope intercept form. We have to get rid of the 3. I guess I could have kept that 3c expression and then come back and substitute it for t2. It would have been the same. So 3y equals 2x plus 6, right? This is my new expression. We can take the x to the other side. So 3y minus 2x is equal to 6, right? Now the question is whether 3y minus 2x is less than equal to 6 or 3y minus 2x is greater than equal to 6. How do I know that? Because this is a solid line, right? So it can only be greater than equal to or less than equal to, right? Because it captures the origin, let's go ahead and substitute x equals 0 and y equals 0 in both these cases. So 3y minus 2x, right? Less than or equal to 6. Substitute 0, 0. That means 0 minus 0 less than equals 6. 0 less than 6. Yes. 3y minus 2x greater than equals 6. 0 minus 0 greater than 6. 0 greater than 6. No, it's a false statement. So wherever the statement is true, when it captures the origin is 3y minus 2x is less than equal to 6, and that is the correct answer. Now, here's what I want to put the takeaway. We got to this form, right? Remember, in the previous cases, when we have greater than or equal to, we can just say equal to solve for y equals, the slope intercept form, right? We're just doing the reverse of it. We basically don't know at this point whether it's less than equal to or greater than equal to. So we wrote two expressions. From there, because this line is not passing through the origin, we are at the liberty of using xy as 0, 0, and that's precisely what I did. So I substituted in both expressions to determine in what case it's true and in what case it's false. The true statement appears to be 3y minus 2x less than or equal to 6, hence that is the correct answer. Okay. Again, we have two ordered pairs, -1, 0 and 0, -1. You're welcome to pause the video, work it out, and see if you got it right. If you didn't, I highly recommend you go back to problem 2. If you don't understand problem 2, where I have given all the explanations, you won't be able to solve problem 3. So this is x1, y1, x2, y2. So slope equals y2 minus y1 over x2 minus x1. It's -1 minus 0 over 0 minus of -1. It's -1 over 1, which is -1, right? So slope m equals -1. So y equals -1x plus c, right? So substitute either one of the two ordered pairs. So let's take 0, -1 for xy. So -1 equals 0 plus c. So c equals -1, right? So our slope intercept is y equals -x minus 1. So y plus x equals -1, right? Now the question is, it's a dotted line. So these two are out of question. So y plus x can be less than 1, less than -1, or y plus x can be greater than -1. So because this does not go through the origin, we are at the liberty to use 0, 0 for our xy values. So 0 plus 0 less than -1, 0 plus 0 greater than -1. This is 0 less than -1. This is 0 greater than -1, which is true. Is 0 less than -1 true, or is 0 greater than -1 true? 0 greater than -1 is true statement, which means the other is false statement. So what does this corresponds to? That corresponds to y plus x greater than -1. So the correct answer is y plus x greater than -1. Does that make sense? All right, let's continue with this one. Again, this line is, we are given one ordered pair, and the other ordered pair is 0, 0 because it is going through the origin. So this is, I prefer to write it this way because I'm used to it. x1, y1, x2, y2. So 2 minus 0 over 1 minus 0 equals 2, right? So m equals 2. So y equals 2x plus c. you're welcome to substitute one of the ordered pairs. So 2 equals 1 plus c, so c equals 1. So y equals 2x plus 1 is the expression. So y minus 2x equals 1, right? Okay, it's a solid line, right? Let me make sure that I did my, oh, this is 2. Sorry, c equals, I was wondering, so it's 0. So y equals 2x, right? So y minus 2x equals 0. Because it's a solid line, we can have y minus 2x less than or equal to 0, or y minus 2x greater than or equal to 0. Please don't do the mistakes I do occasionally, which is make a calculation mistake. In this case, the 1 didn't cost me because there's not a single intercept that was 1. So I went back and figured it out. Most likely won't be the case for other problems as well, but always make sure you double check your work. We're all prone to make mistakes. That's why we're humans, but try to make sure that your mistake doesn't cost you much. So go back and fix it if you can. All right, because this is running through the origin, we cannot use 0, 0, or we can use anything other than 0, 0. So the next best would be to use 0, 1. You can use anything but 0, 0. So substitute 1 for 1 minus 0 less than or equal to 0, 1 minus 0 greater than or equal to 0, 1 less than 0, 1 greater than or, which one is true? This is true, right? So which corresponds to this. And so y minus 2x is there 1. Okay, here's the problem. Y minus 2x is greater than 0 is the correct answer, but in all the cases, well, clearly 2y is incorrect, so we can eliminate these two. Only these two are possible, but you notice y minus 2x, but the x is shown as positive, right? That means if you multiply by negative throughout, we have to flip the sign. That means I am multiplying by negative throughout, so that means it's negative y plus 2x less than or equal to 0. In other words, 2x minus y is less. Now it's in the correct form. Do you see what I'm saying? So B is the correct answer. You have to do all of these changes to make it work, okay? Thank you for watching. Please consider subscribing to my channel, and I'll see you with another video on linear inequalities and graphs. So please stay tuned.